Good afternoon to everybody. Welcome back to our session 5, friends. Just a small ping to ensure you can hear me loud and clear. That will be wonderful. Good afternoon to you, Sandeep. You had sent me a message sometime back. I just saw it right now. Good afternoon, Pani. Good afternoon, Kaushik. Hi, Srilal. I'm doing absolutely fine. Fantastic. Very good afternoon to you, Gaurav. Hey, wonderful. So the news is that I have changed my line to a 4 Gbps line. So during the class, you won't hear me asking you very frequently, can you hear me loud and clear? The breaks in the voice that we had before, all of those things are things of past now. So that's something that we have progressed to. Good afternoon, Vikas. Lovely, guys. So I think what we should do is we should get the ball rolling. So just to confirm to you, the timings we'll be having from this week and the next week is from 2:30 to 5:30 because I'm a little bit tied up a little bit earlier than this. So starting at 2 was a little bit of a concern, so wanted to give a little bit of a gap. Hope that's fine with all of you. 2:30 to 5:30 should be fine, right, participants? A small yes would make me happy. Thanks, Kaushik. Thanks, Sandeep. Morning would be a challenge, Pani, because I've got something else lined up than that. Vikas wanted a break in between, so maybe a 5 minutes break after 1.5 hours, Vikas. Thank you so much. Hey, yeah. Even I realize that a 5 minutes break would be wonders. We can stretch our legs, so that's what we will be doing, folks. A 5 minutes break, so that that will bring everybody back to the speed. Once we come back, we can have our tea also at 4 o'clock at that time. Okay, so we have got almost all the participants over here. Pankaj, Madhu, how are you? Madhu, you had sent me a mail and I have replied back to that. I have spoken to the Eureka management and hopefully within the next 2 days we should have the Google groups ready, and some of the posts that I've been interacting with all of you at the individual level will be sent to the group also. So everybody would be able to talk between themselves. You're welcome, Madhu. Absolutely fine. Hi, Abhishek. Hope you can hear me loud and clear, Abhishek. Pankaj has gone offline, so maybe he should be back soon. So let's get started. A couple of you had sent me the answers. It would have been wonderful if all of you would have practiced. I'm sure you would have done that. So let's start with the week 5. Again, the same set of admin stuff. So you almost all of you would be knowing this. I'm not going to spend much time on this. And just to give you a quick overview as to where we are, we have finished with the MapReduce last week and we started with the basics of PEG last week. We're going to dive deep into PEG this week, okay, and do a couple of demos, and we will, if time permits, and I'm sure it will, post the break, we should be starting with Hive, giving an overview of Hive. But like last time, I'll be sending you the whole presentation of Hive so that you can go through it and it would be helpful for you. You'll be able to understand that. Hope that should be fine. Any questions on what we have done till now other than PEG? PEG, I'm going to revisit it again today. So if you have any questions that you can ask me now, or else we can move on. So any questions, folks? Either a yes or a no from the participants would be wonderful. Okay, so please go ahead, because you had some questions. If you can put it on the chat window, we could discuss. Sure, Vikas. Just to take you back, partitioner and combiner, if we can put it across to the support, we already have in the database an example of combiner and partitioner. I can share that with you, Vikas. A combiner is something which is used as a mini reducer, and a partitioner is there so that it will tell you which exact reducer you want to go to. So that's an example of a combiner and a partitioner. We can definitely share that with you, Vikas. Trevor, how are you doing? Sandeep, Sandeep has already said hi to me. Pankaj is still shown as offline, I don't know. Okay, that's wonderful. So you're working on a fuzzy matching solution based on Hadoop. That will be wonderful. Hi, Abhishek. Hope you're doing good. So since you don't have much of a questions, I think we should start with the agenda for today. So we saw PIG last time, and what we saw as a brief description was that it was a data flow system which gets converted into MapReduce jobs. And the reason it is important is because a lot of companies are collecting huge amount of data sets in the form of click streams, search logs, and you can use it for ad hoc processing also. So this is something that we have seen last time, so I'm just covering it up just to give you a feeling of what is PIG. Again, what can I do it with MapReduce, and why should I go for PIG? Again, the same slide what we have done last time. The biggest advantage is because of the need for MapReduce to be Java based, you could go for PIG so that you could, whatever you're writing it in a Java in a MapReduce function, you could do that in the PIG Latin language, and it gets converted to MR at the back of it. I hope this is all clear. Now, just a quick summary of what we have seen. This is a new slide than what we have seen the last time. I just wanted to summarize it. Give me a second, guys. My GoToMeetings window got hidden in the back. Okay, there it is. I've got that back. So just to summarize, what is PIG? It's a high-level language which totally abstracts Hadoop working. It's a data flow language. We saw that you will tell it individually what you need to do. It's not like a procedural language, not like SQL wherein you tell something and it knows how to do it. It gives you a lot of good operations like join, sort, group, which was not there in MR at the heart of it. You could use existing user code or libraries for a lot of non-regular algorithms. It operates on the file system that is on the HDFS used by Yahoo and given to the open source, and they use PIG for doing most of their job. So Sandeep is asking me whether companies use PIG or they do the RISE MapReduce programs more often. From what I have seen, Sandeep, is that it's a mixture of both. So what people do is they load the data into the environment so that ad hoc analysis, like when we talk about the JP Morgan, like you might be aware that last week I had gone down to Bangalore. I was in Bangalore for 4 days for the training. So when we interacted with the team, they wanted MapReduce program library to be created. So they wanted a set of, so there's a set of code developers who will be writing purely MapReduce programs. There will be a set of ad hoc analysis that needs to be done. So that is what is going to be done using PIG. So for unstructured data, PIG is the best source. So they would take it up to PIG and they would be doing the analysis. Because we're saying, can we have a PIG equivalent word count program? We could definitely do that. PIG is basically whatever is the word count that we're having. As you would have seen in the exercise and in the examples that I had shown, you need to load them. Once you load them into it and you do some dump or a store, so whatever is the initial analysis that you're doing, that will be available and in the HDFS, and then it will be quick to work around with the analysis. Analysis becomes very fast. So again, a small request for Vikas. It would help you to, if you can send me an email on that, I will remember that. So just as a gentle reminder, if you can do that, I can have it and send it across. Once the group comes up, I'll send it across to everybody so that everybody would be aware of that. Thank you so much, Vikas. So that's how. So for ad hoc analysis, when you want to do something, when business analysts needs to work on something, they're planning to create a UI, Java-based UI, using at the back of it, everything would be done earlier than that, loading the scripts, doing the pig analysis, and then dumping the data. We did last time dump command. There's a command called as store, what I have explained to you, which will store the results. So that's how companies work right now. Good. This slide is simple. So let's move on. Now again, the most important thing is when we already have MapReduce, why pig? I think we have covered this last time, but then let's discuss it once again. MR requires Java programmers, so they needed a solution which would abstract the programming language and create a system where users are familiar with the scripting code. So that's the original motivation for pig. Other than very trivial applications, MapReduce requires multiple stages leading to long development cycles. So if you use pig, you can do rapid prototyping. Your productivity would be increased. This is looking from the pig perspective, okay? So if you look at the counter argument, what could be given by MR would be that, hey, there are some things what MapReduce can never, pig can never do, like doing an analysis on unstructured data, okay, where you have got better control. So it is not a simple join. It's not a data that is there. The data is in a binary format. So for those things, MR is still good. So if you want to do prototyping of stuff wherein you have got the structures using Scoop, you have retrieved it. The example that I gave you in the session earlier was that they have got a Sybase database, 10 million records, imported into a BI tool called as Informatica, written into HDFS, and then analyzed. Okay, so that's what is the advantage of pig. So if it's pure data kind of things, yes, prototyping would be wonderful, but MR has got its own advantages where if you want a finer control over things, yes, you have to go down to the MapReduce. So in MapReduce, users have to invent common functionality like join, filter, etc. Because you try to understand why did MR come. The MR never thought about a join or a filter kind of a thing because it was coming as something as a replacement for database. They didn't think it from the database perspective at all. So that's the reason why in MR those things are not there, whereas in pig it is available. Sandeep had asked me, Informatica is able to write it into HDFS? Yes, very much. In fact, all the BI vendors have got a driver through which they can write or read directly from the HDFS. So Pentaho has it, SAS has it, Business Objects has it, and Informatica has it. Even Teradata is having it. You would have seen some kind of a report between Cloudera and Informatica, which they are talking about map databases. So no SQL kind of a world. So that is also there quite frequently. But then yes, most of the BI tools have that, Sandeep. So this was the reason why pig came about in the first place. Okay. So where should I use it? Again, the same slide what I had explained last time. Since it's sitting on top of Hadoop, it makes it possible to create jobs to process large volumes of data quickly. So the use cases where you can use it is if you want to do some data loads which are time sensitive. I had explained this last time. One of our colleagues had asked a question also. Processing from multiple data sources, or you want to do some analytical through some sampling. So those are the cases where I could use pig. The last but the most important thing is pig doesn't need you to sit on the cluster. You can sit in a client that is outside the cluster. In fact, that is the important thing. All of the other ecosystem components requires to be there on the cluster. Pig doesn't need to be there on the cluster. Okay. You're welcome, Sandeep. So that's where I should use pig. So a quick recap of what should we use it for. in addition to the items mentioned above, you could use it for prototyping of algorithms. So as data science keeps on evolving, a data scientist is a role that is a definite possibility. It was not there earlier. Now data scientist is a definite role that would be there. So you could prototype algorithms for processing. So once the data source is available in the HDFS, you can write different algorithms and keep it in a pig script, and you can run that. As you know that there are 3 ways in which I could run pig. I could use a grunt shell, that's one. I could use the embedded pig, or else I could use a Java program, or else using some editor I could use it. So I could prototype it. You could use pig for log analysis. Again, some ad hoc queries across various large data sets. Like I said last time, analytics including through sampling. And PigMix provides a set of performance and scalability benchmarks, and right now it's 1.1 times the MapReduce speed, because they have put in all the best practices internally, folks. So that's what is the advantage of Pig. So just hi Pankaj. I know there was a little bit of a connection issues for you. I could see that you had logged in and then it shows that you were offline. We are just starting with the pig, and some of the slides are new slides, so you could go through the recording. If you have anything, feel free to touch base with me, and we could take it up further. Fantastic. Let's move on. So what is pig used for? So this is what I just said some time back. The beauty of pig is that pig resides on the user machine. That's going to be outside the cluster. You would write something and that would go down into the cluster, and so that you don't have to install anything extra onto your cluster. So that's the most important thing about pig. You don't have to install anything additional, friends. Okay. So what you could actually try is, you could, if you have 2 VMs, you could actually try from one VM connecting to the other VM and then trying to launch this. So that would be a very good test to prove this point that you don't have to be there on the actual cluster. Okay. Folks, I hope I'm connecting with all of you. 20 minutes. If there is any issues, please let me know. Otherwise, if it's fine, that's wonderful. A small S would be wonderful, guys. Okay. So thank you, Pankaj. Thanks, Abhishek. Couple of questions from Madhu and from Vikas. I will answer that. Thanks, Kaushik. So let's go back. How do we connect two VMs? So when we talk about pig, if you recollect, there was a configuration wherein we have to change something in pig.properties file. Okay. So in pig.properties file, there are 2 entries that you have to do, Madhu, and you would have written localhost over there. Instead of writing localhost, if you give the IP address of another machine, you can have it connected. Can pig be installed only on Linux? Not necessarily. Pig can be installed on any Java-based environment. So from your Java system itself, you can create the jar files and see how you can communicate that with pig. So right now we have tried all with Unix, but then theoretically it should work with, once again, let me think of it. I need to try that myself. To be very frank with you, because I've never done it on Windows. I have always done it from Linux. So from Windows through HD Insights you can do that. So that's something that's news, I think, for a couple of you. There is something called as HD Insights. So one of the companies who have developed the ecosystem is Hortonworks. So Horton has tied up with Microsoft to give a tool called as HD Insights, which is Hadoop on Windows. So there are, in February they came out with a version which would be a Hadoop VM on Windows, and now they have got a full-fledged product. So I think with this you should be able to use all the ecosystem components also on Windows. From HD Insights, I have seen it communicating, but then I would need to test with a VM on Linux and sending it from a Windows environment, because. So a quick test on that would be wonderful. Thank you so much. So this is just to let you know that pig is outside the environment. You just need to connect to it. So this again summarizes it. So when you write in Pig something called as load my file, you know that, you have done it in the exercise. This is going to be loading that particular file wherein you're going to filter and load local. Of course, you would know it's going to be a local file. Group by, for each, generate X count B, and then finally instead of dump you are saying store D into output. So output, I'm expecting it to be a local location on the HDFS. If you want to store it into some specific location, you have to say, give the complete path of it, okay? So what does this get translated to? This get translated to the pig.jar. So the pig.jar parses each line, it checks for it optimizes it, and then it plans the execution. Okay, so the execution plan would be consisting of the mapper, the filter, the reducer, the count. Then it submits that particular jar file to Hadoop, and then Hadoop will monitor the job progress. So if you go down to, when you're running a big job, if you go down to the job tracker URL, you would actually see the jobs being running. So this is how it works internally, folks. Okay, so there is something called as a logical plan and a physical plan. We will have a look at it as we move on. Hope this is clear till now. Wonderful. So let's go ahead. Now, if you look at the various operators, so until now what you have seen is what is general. So now you're going to see something that is going to be different. So let's look at an exhaustive list of what all are the relational operators. So for loading and storing, you can load the data. You would know it could be from a file system or other storage into a relation. Store is what would save that relation to the permanent storage, and dump is what will print it to the console. So either way, it will create a map reduce job at the back of it. You could use filtering for removing rows, distinct for removing duplicate rows, for each to add or remove some fields from a relation, and stream, which is going to transform a relation using some external programs. You can stream the data also. Various types of grouping and joining. Co-group is something which is not there in your SQL also. So you could group data into two or more relations, group, cross, again sorting, combining, and splitting. Standard relational operators, folks. Okay. So this is again the last slide. Pig is made up of two components. One is the Pig Latin, that's the language that you use, and the execution environment. You can do it on a single VM if it is a not a pseudo distributed. If it's a local VM, everything running, you could do that, or else you could do it in a cluster environment also. Something that what we have seen last time. And this is again the same slide. I just kept it so that there would be continuity. So whenever you write a Pig Latin program, it has got a set of operations and transformations which would be applied to the data, and it will return some output. You can either see the output onto a screen, or else you can store it onto a file also. So at the back of it, everything is converted into MR jobs. Again, what we have seen last time, you would have a pig tuple, which is like a SQL record, a compiler which will convert it into a map reduce, and finally, a pig will extract the data during execution from the original source of data. So that's one of the reasons where pig is going to be executed is on the map reduce programs. You don't have to load the data onto the pig environment. Because I had a question. To be clear, in a cluster multi-node environment, pig client will be only connected to the name node. Exactly. It will only be connected to the name node, as you will see in a couple of slides. That in the pig.properties file, where you will have to make an entry. In Cloudera VM, everything was done for you, so it was abstracted for you. So whereas in an actual environment, you will have to do that. So I will point it out when that particular line comes. So like a normal client, pig is going to be a client to the HDFS. So it will only talk to the name nodes. It needs only the name node URL, and it would need the job tracker URL. Because So this is the distinction. If you talk about plain SQL as what we have seen last time, SQL would need the data to be there when it is going to be fired, and Pig would need the data only when it is executed. So it extracts data during execution from the original sources, and it stores the data. So it doesn't bring the data onto the client at all. Everything is executed on the cluster, folks. So just wanted to re-emphasize that. This we have seen it last time, differences between Pig and SQL. And this again is what we had summed it up in the last slide last time. If you're talking about SQL, you see here I'm having an insert, inside which I'm having a select from, I'm joining it, again selecting something from users, clicks on where, using, and finally doing a group by. So the problem with this is, and the Pig, can somebody let me know what is the issue in SQL and how is it resolved in Pig, folks, with reference to the example that we are seeing right now? How is it different? Pig gives you a definite advantage. So if you can just let me know what that distinct advantage is. It's there on the screen, guys. The hint is over there. Lovely. Sandeep says SQL cannot save the temp output. Good view. Variables can be used as a command, Abhishek. Lovely. Vikas, different perception. It avoids scanning of all the data. Good. Gaurav says in Pig, each step is clear. We can write, dump, and see the partial output also. Yes. So in SQL, if something goes wrong, the whole query fails. Okay. Whereas in Pig, it is stored in one location and you can reuse it anywhere else. XS Punny, subqueries can be pretty difficult in SQL. Okay, here you don't have to worry about it. It's distinct, and I fully agree with Gaurav. It looks much more simpler, much more simpler than as compared to what you write in SQL, friends. Okay, so this is where we had technically stopped last time. So all of those things would be new now. Is a decode supported in Pig? To be very frank with you, because what dimension are you looking at when you're saying decode? I did not quite follow the complete question, friend. If you can just let me know. Okay, so you're talking about kind of a if-else. This is not a procedural, you're getting that. So basically group and all of those things is what is supported. If-else, I have not seen it being used. It's more of a procedural language when you say if this happens, do this else. It's more of programming kind of a stuff. It is not something related to the data processing. So I haven't seen that because I haven't seen a if else. Let me just think for a second and see if there is anything called as an if else in Pig that I have used before. No, friend. No. I have seen co-group, union, dump, split, for each. No if else. True. So in that way, yes, if you're looking at that dimension, that's correct. SQL has support for if else, whereas as of now, Pig does not have that. That's a very good dimension, Vikas. So we don't have that right now, friend. Okay, another dimension of Pig, we have seen this, just wanted to emphasize it. Since Pig is residing on the user's machine, it can be independent of the cluster. Pig is written in Java and hence is portable. It compiles it into mrjob and submit it to the cluster, and you would there's no need to install anything on the cluster. Just a repetition of what we have said. Yes, you could use a UDF. You're right. It didn't strike me at that time because good for bringing that out. You could create a user-defined function and you could have that logic into the code. So you could write a UDF. So Pani says there are no if statements or for loops in Pig Latin, and he's picked it up from Aurelie. Wonderful, Pani. Thank you so much. Definitely, Srilal, we are going to have a look at what all are the data types that we are going to use in Pig. You'll see that in the next couple of slides, Srilal. Good guys, good. Thank you so much guys. So after running pig, let's analyze the screen. So this is the crux of it. Okay, so the pig letting programs, what do you have? There will be a query parser at the first level which will parse the query that you're having. It will do a semantic checking, and all of those things would be till the logical plan. There would be internally a logical optimizer which will optimize the logical plan. Then there would be a logical to physical translator when you either say dump or store, which will convert that into a logical to a physical plan. And from the physical to the MR translator, the output of that would be a map reduce plan to see whether you want to submit it as one job or whether you want to submit it as multiple jobs. And then it would launch the MR launcher. So it will create a job.jar which can be submitted to the Hadoop cluster. So this diagram shows you the complete internal working of how pig works. Okay. So logical plan, optimization, physical plan, map reduce, and submitting the job, friends. Hope this is clear. So let's move on. So this is the configuration what I was mentioning earlier to one of our participants. So there are three things that we need to do. First, of course, okay, so before I go down to configuration, the difference between logical and physical in pig compilation. Okay, so when you write a couple of statements, right? So let me go back to the earlier slide. Sorry, apologies. I pressed down arrow. I should have pressed the up arrow. And you should see the compilation roadmap. So the logical plan is it will get converted into a physical plan. That means it will get converted into an MR only when I say dump or store, right? So till that time, it needs to put the steps into a logical fashion, and it need not be executed. Nothing gets executed till the time you say dump, right? So whatever you're doing it before dumping, so that is what is logical plan and optimization steps. Only when you say dump or store, that's the time when it will get physical. That's the time when it will convert that command onto something and you will get it back. So how it typically works is people will do whatever after analysis, some results are stored in the file system in HDFS. They will load all of that and keep it ready for you. They will keep some of the variables ready so that you can simply run those things so that you don't have to regenerate anything. So that's the way how it would work, Vikas. Hope it's clear on the logical versus physical separation. You're welcome, Vikas. So now the next slide, which talks about the three things that we have to do in configuration. One, we would of course need to untar and untar the pig file. You would, like in all the ecosystem components, you would have to export the pig install and put it into the path. This is happening by default in the Cloudera VM, but then like I suggest, if you want to create it separately, it would be really advisable to have a separate VM. So in that case, you will have to do this manually. And you see there are two files, pig.properties file, two variables inside that, fs.default.name and mapred.job.tracker, small typos. Let me change that right now because it's pretty embarrassing. Oops. I'll close this. Let me say escape. Why is not escape? Okay. So the things that needs to be done is it is fs, it has capitalized it by mistake, and there should be a mapred.job.jar, guys. Okay, so let me save this and then, okay, I'll say file, save as. Give me a second, guys. Apologies for the additional things what you're seeing. So let me get down to the proper file, and I would want to save this so that in future it is not reflected. Okay, and let me put it into a slideshow. Just removing my additional work after the session, and many times you simply forget it. Okay, so these are the three things. So unless you set the last two things, pig.properties file, it wouldn't know where should I submit my job.jar to fence. Okay. Now, if you recollect last time, how do I run pig? So what are the program structure? One, you can do it with the help of a script. Okay, you can have pig.script.pig, which runs the command in the local script.pig file. Okay, it could be a set of commands. You can use it as a grunt shell, which is an interactive shell for running pig commands. Okay, so you could execute the commands from the grunt shell, or you can embed that into any programming language. So like the way you embed JDBC to run SQL stuff from Java to connect to the database, you can embed pig into your command code also, and that is what is the modus operandi that has been used by JP Morgan in one of the projects what I'm consulting in right now. So they are embedding that so that it becomes a kind of an abstraction layer. Okay, so that's how it's been done. So three ways in which it will be possible. Okay, the pig.script would be there on the local file system wherever you're executing this, Sandeep, because when you execute that, a logical plan is what is created. Okay, so what happens in the logical plan is you would that would get converted into a physical plan when that job.jar goes down to the MapReduce, and it will create a MapReduce code for you. Okay, thanks Sandeep. Because I was wondering, can pig be embedded into MR? In fact, I don't think so, because the only reason is that pig creates its own kind of MapReduce programs. See, we know what is job chaining, right? So what you would want is that within an MR you would somehow want to kick off something which will create a MapReduce. So the objective is not met over here. What is the objective? What is the motivation for pig? I don't want to know MR, and it should be outside. The trump card is that it is outside the cluster. So if it is inside the cluster, okay, then also you could do that. There's no harm in doing it. Only thing is that if you're embedding it within a program, how are you going to run that pig? Okay, so it becomes a little bit difficult. I think it is possible. So technically speaking, it is possible, but then we need to understand what use case I should use it for doing it. So what Vikas is of the view is that I would want to do some pre-processing of data, which is much more easier in pig. So then what you should do is that don't embed it into an MR job. Okay, so embed it into a Java program. Okay, at the Java level, and you could run that particular command. Don't try to couple both those things together. Okay, if you couple that in the same jar, we need to test all the interdependencies, right? Because Yep. In the driver code, run the pig first, okay, pig command, okay, because you can embed that into Java, get the processing of the results, and then go ahead and do your normal MapReduce program. Exactly, Vikas. Yep, lovely. So that's a good way. That's a different dimension. I had never thought of doing that because for us the primary thing was that it's a business use case, and business analyst needs to look into it. So we never thought of using those things inside that. But then yes, that's a different dimension that you can think of, because good idea, good one. Okay, so three ways in which I could use it. So here it comes, Srilal, the different types. So we have got the scalar data types. So we have got int, long, float, double, char array, and byte array. Okay. The reason why we are again not tightly coupling it to Java is because it can be written in different languages. Okay. So although it's a simple pig script, but still it's not tightly coupled to Java. Okay. So some of the scalar types. The next one would be some complex types. So let's look at the three complex types that we have. That could be a map, which could be a associative array, a tuple, which is nothing but an ordered list of data, and a bag, which is a unordered collection of tuples. So you could see here an array of an array. A tuple is nothing but a collection, ordered list of some data. Okay, you don't have to have the similar types inside a tuple. A bag is an unordered collection. You can have it in any order. And the beauty is that the tuples in a bag do not even require to have the same schema or the same number of fields. Like in this tuple here, you could see I'm having an ID, a name, and a number. And look at the third one for Rod Stewart. I'm having an ID, a name, a age, and a role also. So this is just to prove the point that tuples in the bag do not need to have the same schema or the same number of fields. And it can represent both structured, semi-structured, or unstructured stuff. A map can be any key value associative array. Okay, a simple map in the normal programming sense, because okay, key value, that's what I meant by associative. Hope that is clear. Same data type across records, yes. The key has to be unique. The value can be the same in some cases. Some key value pairs across some scalar data types. That's what is a map, an example of an associative array. Fine. Same thing for tuple also. You're right. Sorry. So now, after seeing the two categories what we have, we are going to show you the different ways how you can load your data into a pig. So you could say load myfile.txt, okay, without a structure. You could say load myfile.txt as f1 of an int, f2 as an int, and f3 as an int, and I can use f1 later on. You could load the same using pig storage. That means pig storage is typically a comma separated value where there would be a specified separator. And you could say the fourth variation is loading it as a pig storage as something. So a couple of ways in which you could load. This should be simple because you have already done the exercises a couple of you. So you would take that. So Srilal was saying in the first case what type it would take up its own default type without you specifying it. Okay, so in most of the cases it will take it as a char array. Okay, simple like strings. If you would want to use it as a particular type, then you have to specify that as an int. Okay, lovely. Now, yes, char array is the default because it's like a string. Okay, we can see the structure using describe Srilal. Okay, you would see it here. In fact, no limits to the number of columns. Yes, very much. So you can see over here, what am I doing is I am in a pig. As a hypothetical example, I have got in my mount path retail/cust, and I am loading a, let me get the question separately. Sorry guys, I clicked on something because of it the questions went away. Okay, it's back for me. So what I'm doing here is I'm loading the cust as a array which will have customer ID, first name, last name, age, and profession. Okay, and then what am I saying? I want in a variable called as limit, LMT, I want it to limit to the top 10 customers. And when I say dump, that's the time when it is listing the top 10 customers for me. And then I just need to go down to the reducer and check it out, and you will be able to see the LMT. Okay, then you could also do a group by profession. Okay, you're going to group customers by profession. Then you can count by profession. You're looping through the group by profession variable. You're generating the group count of customers. And then the moment I say dump, that's the time when it would fire a map reduce and show the output to me. But then it's not stored in the HDFS. If you would want it to be stored in the HDFS, you will have to say store count by profession into output. so that it'll tell you where it is actually stored, friends. Okay, so this is just to show you an example of how pig would work, and you could see it very clearly in the example that the file, the comma separated value, is going to contain the ID, the first name, last name, age, and the profession. So you can have a simple comma separated value, create about 20 or 30 records, okay, and then you can actually test it out. Okay, so this is how you would actually be running pig. I'll show you a demo once I finish this. If I am not mistaken, I showed you a demo last time. I can show that. Of course, some of you have done the exercises. So just wanted to check right now from the participants who are there, how many of you have finished with the exercises, friends? If you can just tell me an yes or a no, or if you have any issues with the exercise. I saw a couple of them coming to me. Okay, so we have got 4 people who have answered. 3 of them have said yes. Others, if you can answer, friends. Okay, Pankaj, if you can go through the recording, and if you have any issues, you can, we'll see how to finish it. Madhu is going to try it today, no problem. Srilal tried it but didn't get the final result. If you get stuck somewhere, let me know. Pani had done a small exercise. I'm fine with that, no worries. Yep, Pankaj. So you are back from the native place. That's wonderful. So no problem, Kaushik. Let's try to finish it off today. So because otherwise, Hive and Pig both next week would become a little bit heavy, friends. It should take comma as, or else you could see tab, because what Pani is saying that it's taking tab as default, it's not taking comma as a default separator. So what you need to do is you need to say pig storage and then put it into a single quotes. So when you say load something, okay, so all that you need to do is that you could say load using like the command that I have shown over here. Okay, you see as so and so. Only thing you have to say is I haven't shown that over here, but then load cust load so and so. You could say using pig storage, okay, in the bracket single quotes comma single quotes as. I'll just put it in the chat window for you, so that's a solution for you, Pani. So let me just do that. I'm just going to say cust is equal to, I'm just typing it out for Pani, load from wherever you are. Let's say it is there in my input slash cus is what is the name of my file, and this should be single quotes, not double quote. Just a second, friends. Just a comment so that Pani doesn't get stuck. So I'm going to say using pig. You'll see what is pig storage very soon. Using pig storage, and in the bracket single quotes comma single quotes bracket close as. So I'm just sending it to everybody so that you would get that. Okay, it's not taking up a bit array, it's taking, it's not taking a char array, it's taking a bit array as a default, Pani. I need to look into that. From what I had understood when we were playing around with this thing, is that you used to take a char array as a default, but Pani just is confirming that it is going to take a bit array as a default. Let's see it in an example, friends, that the default type that we were discussing earlier. So Vikas says in a CSV file input, if the data has comma, can that be handled? What you need to do is you will have to build it up into the logic, Vikas. So by default, it will think as the comma as a delimiter itself. So you will have to, when you're loading it, you'll have to do it in a proper way. But there are ways to do it. Definitely yes, Vikas. So if you get stuck somewhere, send us an actual code and we can definitely help you out with it. Good guys. So after running pig, I'm just going to show you again, this is what we have seen earlier, how the commands are being executed, but then I would just want to show it to you once again. Just give me a second, guys. Again, my window got vanished. Yeah, it came back. That's wonderful. So a pig command, as we all know, is a collection of statements. It could be an operation or it could be a command. Okay, an operation is the load or using any of the operators. It will have a logical plan and a physical plan, and as a statement is processed, it will keep on adding itself to the physical plan, and only when a statement such as dump or store is called, the logical plan is converted into a physical plan. A quick repetition of what we have done yesterday, but then I thought that the slide should be there so that it will become more easier for you to understand. So a couple of relational operators. I'm just giving some names over here. As we go ahead in the exercise, you will see some of the actual values of it also. Okay, some examples of it also towards the end of it. So you could load and store as what we have seen earlier. Some filtering. You have already seen a chart of this earlier, but again a re-emphasis on it. Grouping and joining, sorting, combining, and splitting. This is the complete exhaustive list of your relational operators. So this is something that you would need to know. So in pigletting, if you look at the relations and the schemata, the results of a relational operator is a relation. And the relation is always a set of tuples. The relation can be given a name using an alias. So what are we doing is when you say x is equal to load sample.text as ID and as year, so indirectly ID the x is what is the alias, and the tuple, which is a collection of something, is what will be shown to you as if you're printing it out and if you're dumping something in sample.text 1, 1987, that is what is a tuple. And like I said earlier, you could describe the relation in a schema by just saying describe x, which will describe what is the schema behind that particular alias. Okay, so this is the way how you could do your relations and schemata. Some examples of grouping and aggregation. So when you talk about group, the alias can be via a field alias. It can be grouped by multiple fields. The output key has a key field named group. Okay, so if I say group by profession, group customer by profession, that means the output key, whatever is happening, the profession here is group by profession is the alias. You are going to say group by profession, which is going to be the output key here. And if you would want to control what you want to be shown in the output, you could use for each. So in the example of count by profession, I'm saying in every group by profession, I want to show only the group and count of customers. I'm trying to do some aggregation over here. Okay, so you can do that if you want to control what you want as output columns. And just a summary of what all are the built-in functions that we have in PIC: average, concat, count, def, tokenize, isempty, etc. Okay, so this is how your grouping and aggregation can happen. Because I was asking, can we do away with the start and the trailing brackets in the output? Typically, yes, that is just for demonstration. So if you would want to say, typically if you're dumping something, it's going to dump you only the records. The describe is what is only going to give you the trailing and the starting brackets. Okay, in the actual value, it won't do that, give that for you, Vikas. Make sense, friend? True. So let me just go back. So when you say dump, you're saying that you will have the alias would, since it's a tuple, you're talking about this example, right? Wherein when I say dump x, yeah, exactly, 1, 1987. So even in the assignment, if you are dumping the x, this is what will be shown to you. But however, if you store the value, you won't see the starting and the trailing brackets. Okay, so it will simply store it as an individual value, and you can cat it to actually check it out. Did you check out the output? Okay, Vikas, you can actually check it out and you will see that. Thank you, buddy. Okay, now you could also do some filtering and ordering. So if you would want to select the tuples that is loaded based on some Boolean operations, you want to select or remove something, you can say filter customer by age less than 20, and count by profession by count greater than 1000. Okay, so some simple examples of how you can do filtering, and you can do an ascending and a descending sorting, which can be on more than one field also. Okay, so some examples of filtering and ordering. It's very exhaustive, as you can see. Similarly, you can have a for each and a distinct. So if you want to go through an iteration, you would have a for each. There is no for as what was mentioned earlier. So for each you can generate for controlling the output, and distinct is to ensure that duplicates are removed. Same thing like what we have in the SQL analogy. So for each distinct. The biggest advantage of Pig is its ability to create a sampling of a large data set. Okay, so you could very simply say, if I want 1% of the total data set, whether instead of you trying to pick up randomly something, it will return it for you. So you could say load data as you give it a structure, and then when you say sample a 0.0.1, it will give you 1% of the data and store that into X. So this is quite useful wherein cases where you want to get some, let's say I got say 10,000 rows and I want to get a sample which is uniformly spread across all the values present in that particular data set. I could use some sampling technique. Exactly. In fact, because right now there are different ways in which you could pick up the samples, but then this is something which is there, but then they have not fine-tuned it much. So it is quite naive right now. But then it gives you some values to start playing around with. Okay, so if you would want to say I want 10% of the records from this column, any 1% from these columns is okay. So it's picked up randomly right now. So the rules are there. It is getting improved, but then it is very random right now with us. Okay, but then yes, the biggest advantage is that it has got some sampling techniques, friends. And like what we saw earlier, if you need something what is not there in the original set of functions, whatever has been given by Pig, you can create your own user-defined functions, and I'll show you how to create some UDFs in an example at a later stage. So for any logic that cannot be done in Pig, okay, you can create a UDF. It can be used to perform some column transformation, filtering, ordering, or some custom aggregation. Take an example. If you would want to write custom logic to do interest calculation or penalty calculation, let's say 1% of the data set, you can simply have it create that particular UDF function, and then you can say interest is equal to for each customer generate customer ID, comma, calculate interest based on the customer account number. So if you would want to load that particular function, first there's a command called as generate. I haven't mentioned it here now. It will be there in another slide. So generate is what ensures that that particular jar file which is there on the client machine goes along with the jar file so that it would be fired, because the data set is on the cluster. You want to fire it. So it will go along with the job.jar and gets executed on the cluster, friends. So you will have to generate that particular UDF so that it will go ahead and see it. I'll show you an example how to actually do that, because, and like I said, there is a very good example of creating a UDF in the definitive guide also. So examples are there, so you can try it out. I'll show you an example in the form of a slide. Please try it out. If you get stuck somewhere, we are always there to help you. Okay. So that's what is the UDFs. So this is about, if you recollect, I said something you have to, not generate, the actual name is register, apologies. So if you look at UDF statements over here, I have broken this into diagnostic operators and UDF statements. So the types of diagnostic operators can be describe, explain, or illustrate. Okay, so this gives you diagnostics on the particular execution of pig. And for pig UDF commands, you can say register. That's the way how the jar file can be registered with the pig runtime, so that when the job.jar comes, it gets copied, it gets merged, and it is sent to the cluster. Okay, you could also use define for creating aliases for a UDF, a streaming script, or some command specification, guys. Okay, so something new what we have seen. You explain and illustrate. Please play around with it, folks. Try with all the commands so that you'll get a hang of it. Now comes the pig storage. Srilal, this is what is the load file loaders. So when I say bin storage, okay, there are various types of pig Latin file loaders. When I say bin storage, you're talking about a binary storage. When you're talking about a pig storage, you are going to load and store data that is delimited by something. So by default, it was delimited by tab. So if you would want to delimit it by comma, you should say pig storage. You could say text loader, which loads line by line delimited by a /n or a new line character. You could load a comma separated value file, or else you can even use a XML loader. Okay, so these are the various types of loaders what we have in pig Latin. Now a couple of examples. I have given the type of examples earlier, whereas this is simply going to give you an example so that you can actually play around with it. Okay, so you could see here that I am going to say load student as something, name, age, and GPA, and when I dump A, it's going to show me these values. So the GPA is not there for Sam and for Bob, it's only there for Joe. Sorry, the age is not there for Sam and Bob, whereas it is there for Joe. Okay, so you could actually create a sample text file like this as student, and then you can actually play around with it, folks. Okay, now if you would want to group by age, and when you say X, you see that how it is getting loaded. Okay, so you could see that it is getting loaded as a bag unordered collection of tuples. Okay, so this is some examples of loading and group by. Let's take something more. So an example of co-group, which I said was originally not there in our SQL world. So you would say load student as so and so, then B load student as so and so, and then you are dumping it. Okay, then you could co-group A by age, B by age, and then you can dump X. So I'm dumping two things. Okay, and then I am co-grouping it by it. So you can see the kind of how the co-group array comes about. We will actually see this in another example of, I've got another slide for co-group, which will give you a little bit more exhaustive explanation of how you are going to do co-grouping of two kinds of aliases, okay, into one. Typically, it's like a kind of a join, but then it's distinct. So you will see it in an example in a couple of slides now. How does co-group work? So this is basically join. That means bring everything together. Okay. So co-group, you saw how the array was created when I dumped it. Now, when I do the same thing as a join, okay, I'm loading both in A and B. Okay, and then in X, I'm joining A and B by age. So you could see how it gets created if I use a simple join versus how I do a co-group, guys. So you will have to see one example yourself on the co-group and the array. The exercises will test you on the basic functionality. We are working on more advanced exercises also, but then with this operators, with some sample data that you already have, we can start playing with a lot of these individual functions. Please play around with it. If you get stuck, we are always there for you. Okay. So this is a slide that I was talking about, the difference between a co-group and a join. So co-group takes advantage of the nested data structures, combination of group by and join, and user can choose to go through can choose to go through which cross product for a join and perform aggregation on the nested bag. Remember I told you map, bag, and a tuple. So let me run through the slide. So you can see here group data co-group by two things. Okay. Then on the other hand, temp variable and join result, you are flattening it or something. Then you again have a join result. You are again joining the results by query string and the revenue. And this diagram tells you how it is actually going to work. Okay. So if you look at the group data, if you look at the results, okay, and if you look at the revenue, this is how the results and the revenue are. When you say join, see how it came into only one. Okay, we saw that in the simple example earlier also, but when I co-grouped it, you saw that how for an individual key, okay, this is the key, how it has created the group data which I had co-grouped it. Okay, it is taking up that group data into two separate arrays. So it is taking the unique key and putting the values and grouping it together, co-grouping it. Whereas for the second value, that is kings, you can see the same thing is happening. Whereas in the case of a join, everything gets joined together. So that's why I said an example is what would make it very clear for you. So before I move on, I just wanted to get a go-ahead from you if you're clear with the difference between co-group and a couple of operators what we have seen earlier, friends. Any clarification, I'll be glad to give it to you. But then I would say please practice these things. That's the best way to understand. A quick confirmation from you folks. Is it fine till now? Take your time, Vikas. Take your time. No worries. So you need to look at the slide, go through it comfortably. Only two people have answered. Yes, Funny, you would need to look at the sample data set that is already there with you and play around with these things. Abhishek is asking me what is distributed revenue. You would see the, hey, where is this? Okay, fine. So that is just as what is showing you only the site and the value. So let me look at where is the distributed revenue variable that I'm coming from. I'm not using the distributed revenue. So this was there in the actual slide that I have taken. You can ignore that for the time being. Okay. Again, flattening is an extended version of how do I break it up into individual values, key values. Flatten means breaking it up into individual key values. Okay. So you could see the joint result, how I'm flattening it by results and by revenue. That means every key needs to be flattened out, friend. That's for Madhusudan. Vikas says, is there a key, a bag, and bag as the output? Typically in a co-group, there will be a key. The whole thing is a bag, okay? The bag would have a tuple. The tuple would have, it's an unordered collection of tuples. That's what is a bag, okay? The tuple would have some set of things. So that's how it is, Vikas. So not necessarily that there should be a key and a bag and a bag. So in my examples here, for every key, there could be a set of tuples. So you're co-grouping something, right? So the way you're co-grouping is I want to have some unique things in my results. So let's see what are you co-grouping. You are saying co-grouping your results and revenue both by some query string. And the query string in my example is Lakers and Kings over here. Okay. So I'm co-grouping both the results and my kings, and I'm bringing that with a unique key called as the query string. Okay, so in the original table of results, there were three things. In the revenue, there were three things. I am co-grouping it by query string. So that's how it is simply coming together. Make sense? Because it's a kind of a functionality that is available. Okay, typically you would want to co-group when you have got two separate columns, and what do you want is whatever is a unique thing in both the columns, you would want to bring it together. So if you are trying to look for an example, if you take up this example itself, okay, so you are seeing a individual, let's say IPL, okay, the IPL has got two columns, a column, the URL from where it's happening and what is the rank where it is, and if you want to using the revenue, again the same IPL team, what is the ad slot where it is coming and what is the amount of the ad. So two distinct kind of data sets, and I would want to bring it together based on the uniqueness of some column. Okay, so here that's why I'm getting the uniqueness of the column is Lakers and Kings. So it is actually getting the different values from Lakers and Kings, and I'm bringing it together to it. So what do you see in the core group? Just give me a second. Yeah, there it is. What do you see in the core group? You see the key as Lakers. It has got both the columns, okay, in that one line. In the next line, you see it has got Kings, and it has got as its values the exact value from that. So it is just bringing both those things together. It is a kind of a two-dimensional array that you are having. Makes sense? Because I'm trying to put some structure to it. Does it make sense? You're welcome, buddy. So others, if you can give me a quick thumbs up as to how is it till now. Gaurav, Kaushik, Abhishek, Madhu has already answered. Pankaj, Trevor, you have been very quiet today, friend. Srilal has pinged me earlier. Okay, guys, how is it? Can we? What is not, it's a functionality, what is not clear, Sandeep? If we can bring up the doubt, I will do my best to answer it. So you're talking about the core group, right? So, okay, the flatten is another of the functionality which is just to show you, see, if you look at the joined result, okay, in the joint result I am flattening it by results and I'm flattening it by revenue. So typically what happens when I say flatten is the key what is happening. Okay, so if you look at simply the joint results, I'm breaking it up into only the values. I'm removing out the okay guys, yep, it came up. Wonderful. Suddenly the broadband went away. I thought broadband is reliable. Suddenly I realized that I myself saw that. The broadband went away and it has come back now. Hope you can hear me now. Can you give me a yes? Okay, wonderful, wonderful. Thank you, thank you. Yes, Abhishek, I could hear, and Gaurav also. I myself saw the news. I thought that broadband is reliable. Very surprising, guys. Okay. So coming back to what we were, just give me a second. Too many windows, like I said. Let me minimize this somehow. Okay. So the original results table has got three columns. okay, and you have got the revenue, which has also got 3 columns. There is only one common thing what is there in both of these things, okay. So in the first part, what am I doing is the group data is co-group. So you could see the group data which talks about the group, the results, and the revenue, okay. Then you have got the join results, how the joint results would be there. So when I say flatten on results and revenue, so what am I doing is whatever is a common part of it, okay, that is the one that I am taking it out. So first, when I say flatten results, okay, so flatten results would take out the key from it. It is only going to give me the URL, the espn.com, whatever is the sites, whatever is there, those things is what is going to come out. So flatten simply shows me, take out the unique thing and just show me on what you want to flatten. Okay, so in short, that is what is flatten happening. So here you are you're generating something, you're flattening both the results and you're doing it on another level, the revenue. So that's what this distributed revenue is what is confusing. Okay, so since I picked it up from a site, I think I just wanted to show you the logic of co-group and join. So it is a flattened thing which has put you off. So let me see if I can get some detailed explanations on flatten, which I can bring it up for you folks. Okay. So flatten is just removing the key part of it. That's what is flatten. Now let me see the questions once again. So that's what it's doing, Pani. You're right. Flattening is writing each key value pair in a line. So, but then here you are flattening it both on results and you are flattening it on revenue also. Okay. So that's what it's doing. It's taking up the key value pair, whatever is the key value pair, and then it is summing it up. Let me see if we can get a proper example on the flatten part of it, because that's something that even I haven't worked with. We have worked with co-revenue, co-group. Co-group, we have worked in many cases where you have got two tables with two separate dimensions, but the common key is, but you have got a key that is common. That's where I'll use co-group. But if I use my join, the down arrow, you can see the join. Join will join all of them and bring it into one. Fair enough, team, please. I haven't still heard from Trevor. Trevor, you are there, friend. I hope all is well till now. Others have answered me. Madhu, Sandeep. Pankaj, you haven't. Okay, he has asked me. Abhishek is fine. Okay, so just let's not get hyped out on some of these operators. These are all the various possibilities what is available. So this slide was just to show you, because co-group is not there in SQL. So that's the reason why we spent a little bit of time on this. Okay. So now let's get down to the next section. So here, when I say you are parsing, okay, when you're writing a line, remember I told you there is a parsing stage. What it's doing is it's doing some type checking with the schema. It is referencing the verifying part of it to see if everything is fine, and it creates a logical plan. So it creates a one-to-one fashion. The logical plan has to be independent of the execution platform, and there would be some optimization. So what it tried to do is that based on the independent part of it, okay, I'll come down to that, because based on the independent part of it, it will determine how many jobs do I want in the MapReduce program. So you're seeing it's type checking with the schema. So what is schema over here is there has to be some kind of metadata. When you say load, right? You have loaded this as, and in the bracket you said int array, char array, and all that, right? So that's what is the schema type checking, what is happening. So for example, in the code you have said something load as cust id colon char array, right? Or colon long. So that is what is the schema, the column that we are referencing, Vikas. Fine on that, Vikas? Yes, yes. So if the file is taking it as a separate type, and see, typically an int can get into a char, but a char cannot get into an int, right? So it would throw us an exception. Very true, Vikas. Wonderful. So that's the reason why we typically take it up if you're not very strong about some calculations on that. We typically say put it as an char array. Okay. So you see in a couple of examples, most of the commonly used one is char array. Wonderful, friends. So this is just to show you the various logical plans. So I'm just going to go through each one of these things. There it is. You can see. Just bear with me just once again. My window again went at the back. So that's the reason. Just bear with me 2 minutes. There it is. Lovely. So let me look at what you are seeing. Okay. So this is exactly what needs to be shown. So just have a look at this and then we can discuss it, friends. There is a load that's happening. I'm not specifying that type. Okay. There are two loads that's happening. You are doing a filtering on the first alias. Then you are joining that filter with the B and you are joining them on a unique column. Then you are grouping the joined output by another variable. And then for every variable, you are doing a for each, and then you are specifying what you would want to see. You would want to see only the group and the sum of the join, whatever you had created earlier. Okay, and then you are storing the final for each into an output column. So this is what is the logical plan, folks. Okay, it should be simple. No need for a concern on this. And if you recollect earlier, I had mentioned that if you want to see a UDF, I'll show you a demo of that. So this is what is the UDF that we have. So if you are creating a program, again, it's going to be a Java-based program. And you know that you'll have to put that whatever is a jar file so that it will get copied to all the nodes, that is data nodes in the cluster. Okay, so looking at a simple example of an object, checking if it is a type of a data bag or a map. I'm throwing some exceptions. So just checking the empty feature of a particular collection. So this is how you can create a simple UDF. You will have to see, where is the UDF created, friend? It's on the client side. Using the command, it will go down to the cluster and it will go down along with the job array to every node, because that's where this needs to be executed, right? So this is going to be on the client side, guys. Okay, so how do I use my UDF? You will have to use register. We have seen that before. So what does register do, folks? Just to make it a little bit interactive, because we are not having a demo right now till now. So just wanted to ensure that all of us are properly alert. What does register do? Try to explain it properly for me. What does register do? I'm sitting on the client side and I say register my UDF.jar. What does it actually do? Yes, technically there is a filter function that needs to be, is something that you need to extend. Yes, from the coding perspective, Vikas. So Gaurav says register takes that particular program along with the job.jar. Why should I do that, Gaurav? Or what benefit it gives me? because since it carries the UDF jar from the client to the HDFS servers dot jar, wonderful, because when I'm executing the final thing, you would see that it is actually getting called, it needs to go down to the actual nodes where the data is, right? Wonderful. Pani says, okay. So computation goes to data instead of vice versa. Very much, very much. So the logic needs to be going to each of the nodes. Fair enough, fair enough. That's good. So you have to tell Pig where to look for the UDF. For that, use register. Exactly, Srilal. In fact, Pig is going to be converted into MapReduce jobs on the actual cluster. So this code goes to the actual cluster also. Data is stored into nodes, so we need to run it onto the nodes. Exactly. I think that's good. Most of us are there. So you see here, I have loaded student as an array. Then I have loaded voter as so and so. Okay. Then I'm co-grouping A and B by name so that I get that two-dimensional kind of a data. Okay, because the name is the thing that is there in the voter and the student. I'm co-grouping them. And then I am doing a for each, and you could see here I'm using the isEmpty function, okay, that I have defined in the earlier job.jar. That isEmpty function will tell me whether something is empty or not. So this is simply a ternary operator. So it is giving a Boolean operation and deciding whether it is null or not. In fact, flatten inside that has got this capability. In fact, Sandeep, yes, if-else, ternary is a kind of an if-else operator. Yes, yes. isEmpty is the name of the class. Let me go back to the earlier code. So you can see over here, isEmpty is the class in which there is an execute function. So when I'm calling isEmpty, it is actually calling that one particular function because I'm extending. There are multiple ways to write UDF. This is a simpler way just for demonstration's sake, friends. So if you look at the actual note, the book, the definitive guide, he has shown us another way of doing it also. Okay, so there are a couple of ways in which you could do that. This is one way of doing it. Not necessarily Boolean. Since the execute function was returning me a Boolean, it need not be a Boolean. The UDF can return me any of the other type, which you can pass it into any of the other functions for more evaluation also, Vikas. Okay? Exactly, Sandeep. So it was asked by Vikas earlier. So here we are just saying isEmpty on that particular tuple, that is the alias that we got, and I'm passing it directly to get the value, friends. So a couple of ways you could do it very easily using the standard example that we have rather than using flatten. So you don't have to do that. Without that also, creating a simple UDF, you could get that. So my suggestion is to try the definitive guide, big example, create a UDF and then see that. If you get stuck somewhere, please write to me and to support, and we would be glad to help you, friends. Okay. So let's take a little bit more of an example. Okay, so if you would want to, this is a kind of a data analysis task that we are seeing. So what I'm going to do is, let me just walk you through this and then I will take up the questions. So just for your reference, I want to show you, this is one example. After that, I'm going to show you how the conceptual data flow would happen. And finally, a Pig script. This is the last one, okay? So let me go through all the 3 slides and then I will take up your questions. So if you would want to have an example of a data analysis task, first, the visits table has got the user, what all URL, and how many time has been there on that. And then you have got a pages which has again got the URL and what is the rank what you have. Okay. So if I want to find users who tend to visit some technical pages. Okay, so You would load the visits, you would load the pages. You could do a join so that the URLs, you can get into one column how those things would be there. Then you would group by that particular user, and then you can create a average for per page rank. Okay, compute average for that page rank, because page rank is one of the columns that is coming from the load page. And then you can filter the average page rank less than 0.5, and then you can get your results. Okay, so let me backtrack again. I've got the user, some URL, some time, and some ranking of the pages. I want to find out the user who tends to visit some pages. So I load both of them, join them, group by, compute average per rank, and then use a filter for average page rank greater than 0.5. And if you would want to write a script for this, you can load something. Okay, you can use a for each. Then again for pages you will load that particular file. Then you can join the visits by URL and pages by URL. Then you can group the visit pages by user for user visits. And then you can, for every user visit, generate will tell me what all columns you want, average of the vp.pagerank, because in you're joining the visits. Okay, so there's already a page rank, you already joined it, so vp.pagerank as average PR. Okay, that's how you're doing it. And then for good users, you can filter the user page rank by the average PR greater than 5, and whatever answer you're having, you can store it into Pig so that somebody can start analyzing this. So this is something similar to what is been planned in JP also. They would want to take the data from some database, use Scoop, okay, put it into HDFS, and then uses Pig script to pick up the data from the HDFS and run something. Instead of writing a MR program, of course you could write MR program, but then if you would want to do some further analysis on it, writing multiple MR programs was painful. So that's the reason why they thought that we could do that possibly with the help of a Pig script, and the individual business analysts don't have to be there on their machines. They can do it from anywhere else. Okay, so this is the example that we have taken. So let's take up the questions. So let's go back. So you're asking me because what is this average page rank per user? So you can see here vp.pagerank as average page rank. Okay, so what are you doing? Since you're joining in VP, you would have the details of the pages which had the page rank and the user also. So that's how you can get the average of that page rank. The first and the second line. Okay, the first line is simply loading it. Okay, and the second line is, supposing if you had more columns in the data, okay, in the second line I am looking at only that specific columns. Okay, Vikas, you're welcome. So just wanted to clarify that. So there was a little bit of a confusion. Both are visits variable. Why am I doing it twice? Here the assumption was that if you had more columns, okay, I want to generate only these particular columns. For every visit, I'm just looping through it. It's generating these things so that it can be in a kind of an ordered based on the user. Okay. So this is the example of our Pig, folks. So what is that window that is coming? I got no clue. Anyway, that's fine. So what we could do, guys, is we could take up a quick break, okay? Because since there was not much of a theory over here, I had to keep on speaking almost non-stop for about 1.5 hours, okay? Vikas, you saw something called as parallel in Pig. If you can let me know what was parallel. We could look at that. You're talking in from which dimension, Vikas? So for the others, friends, what we have seen, I presume for people who have already done the exercise, they would have understood what the exercise is, stuff that you're doing. People are not done it, please follow with the exercises this week. And this was to give you an overall view of what PEG is. Okay. Sandeep says, so the second visits is like a select column from table instead of select star from table. Very much, Sandeep. Generate is to let you know what all columns I am interested in. Okay. In fact, okay, you're talking about parallel execution of pig scripts. Let me have a look at that particular wiki page. If you can send me a short email with that particular link, that will be wonderful. So I will send it to the others also, the link that was sent by Vikas to me, so that we can also share that. Let me copy that, and I'm going to send it to everybody and send to all. So let me have a look at that. I haven't had a look at that link for quite some time because we were stuck with our existing project, so did not get time. Sure, because no worries. So send me that link in an email. I will have a look at that, and I will revert to you by Monday or Tuesday this week. And once we have the Google Groups ready, I will post whatever is the emails that I send it to the others for some period of time. I'll put it under the group so that everybody will get what we have been discussing. So it's about 4:05 right now, folks. So let's take up a quick 5 minutes break, and I'll be joining you back again at around 4:11. And since you have done the exercises, that's something that you have to try it out, folks. I could show you some demo if you would want, and then we need to get into Hive. So once we come back, we will discuss that. So 5 minutes, we will be starting by about 4:12. Okay. Thank you so much. I'm just taking a break, guys. See you soon. Hi folks, just to confirm that I'm back. Can we have a quick roll call to see if our friends have come back? People are back. If we can say yes, that will be wonderful. Thanks Abhishek, thanks Vikas, thanks Gaurav, thanks Pani, wonderful Sandeep, thank you Kaushik. Great. So now what I'm going to do is I'm going to give you a quick demo on the complete pig scripts. So I showed you a set of things. I have got my own data sets as an exercise. Something was shared with you also. It would hardly take about 5-7 minutes. So I think it's worthwhile getting into that particular exercise. So what I'm going to do is I'm going to go ahead and start with my VM. So this is not my Cloudera VM. I'm starting with an Ubuntu VM that I have set it up myself because I've got the data available in this VM, friends. So that's the only reason why I'm starting with an Ubuntu VM. You see that it's getting loaded up. So I'll show you that I have got a data set called as CUSTS and I have got a data set called as TXNS, okay, transactions and customers, and I'm going to merge both of them, okay, and I'm going to say group by. I'm going to load both of them. I'm going to, for each having some sum, how the spend by customer is there, top 10 customers, lot of things is what we are going to see over here. Okay, so let me actually do that. So I'll see that my Ubuntu VM is coming. So Pani says use schemas to assign types to fields. If you don't assign fields, the field defaults to a type byte array and implicit conversions are applied to the data depending on the context in which the data is used. Yes, okay, wonderful. Thank you so much, Pani. So what typically happened was that I did not look into the actual type of it because it's a byte array. It gets converted implicitly into the type in which you are using. So since we use string or char array as the most common type, I had assumed that the default would have been a char array, Pani. So I'm just going to put it into the window what Pani had mentioned. That's wonderful. He has picked it up from the reference documentation. Okay, that's absolutely wonderful. So now we know that yes, it doesn't take it as a char array. It basically takes it as a byte array. Thank you so much for that, Pani. Appreciate that. So let's carry on. So let me get down into my Ubuntu, and in fact I'm already into Ubuntu. Give me a second. Okay, let me type my login details. Oops, I need to click in twice. So I have logged in. Okay, so now I would need to use PuTTY. So I just need to say ifconfig because it doesn't give you scrollable capability and all that. So the best way is to use PuTTY. So I personally start with the VM and then I will start with PuTTY. Okay, and there it is. Let me minimize it. I need to know my IP config. Hey, I don't want to do the licensing now. Okay, so let me get down into, let me get down into my Ubuntu so that I can get my IP, and let me get into PuTTY. Okay, it is 192.168.14.128, and let me open this as not root, and I've got a password. It should come up pretty soon. Let's see the window as it comes up. Okay, I have put in the password. Wonderful. I can minimize this window and I can maximize my PuTTY window. Okay, lovely. So let me keep this on the side so that I can see if somebody is asking me a question. Okay, couple of things. Now I didn't anticipate that. Let me get down to WinSCP and let me show you the structure of my records. Okay, 192.168.14.128.14.128. Oops, I pressed enter by mistake, I think so. Just give me a couple of seconds while this fellow is coming up. Okay, if it's taking time, what I'm going to do is I'm just going to say pig. Okay, you see that the command it's giving is that's fine. Hadoop home is deprecated. That's fine. It's getting into it, but then I haven't started with my servers. Okay, so let me see. Close this. Close the program. No worries. If you recollect, some of you had seen these errors before. Okay, retrying the client on so and so port numbers. The analysis that I said is, just give me a second, guys. Okay, so this is because I haven't started my servers. Okay, so if I do JPS over here, you would see that I just have got only JPS. So I need to go to my Ubuntu, the Hadoop. So let me get down to CD lab software Hadoop bin, and I'm going to say start all. Start all. So this is what is going to actually start my name node. You see that it's starting my data node. It should start my secondary name node after that. It should start with my job tracker, and it should start with my task tracker. I've got a pseudo distributed cluster over here. And now if I do JPS and I press enter, you should see those tasks coming already over here. There it is, the data node, the task node, name node, secondary name node, job tracker. Now let me say pig, and you would see that it is, it should be able to communicate. Okay, so there it is. See, it is logging something to that, and you see over here, oops, it's saying that, okay, let's wait for a couple of seconds. I'm surprised. It says failed to create data storage. Okay, so let me get down to this log. Okay, Hadoop bin log and see what it is. For that, I need to get into my WinSCP. So let me open up my WinSCP so that I can get into my logs. The IP address was 192.168.14.128. 192.168.14.1. Come on. For the second time, I pressed enter by mistake. Give me a second, guys, please, so that we can see. Just give me a second, guys. Okay, let me close this. Embarrassing, but then I need to do it once again, guys. 192.168.14.128. I hope I don't press enter now. 192.168.14.128. The username is not root, and the password is, I've typed it. I would say login. Okay. Now the logs are there in my Hadoop. The name of the log is connecting to the, what does it say? Let me bring my window down. Come on. It says connecting to the HDFS file system at so and so. Okay, I think there was a little bit of a confusion. Let me go back and check. So today's log, I need to see the size of it. Today is, on the server, it's a different date. Okay, so 19th, there it is. So let me get into the log. It says call to localhost failed. Okay, there's a connection exception. because last week when I was there with JP Morgan, I would have played around with this. Give me just 1 second. In my lab, inside my software, inside my Hadoop, inside my conf, I need to look at my core-site.xml. Yeah, there it is. I had changed that to what do you call the IP address. So that is what was a mistake. So let me quickly do this. Okay, please bear with me. I didn't expect this problem. So let me go down to hdfs-site.xml. That is all the same. And only mapred-site needs to be checked now. In that also I put in this IP by mistake. So let me put the localhost over there. I think then we are all done. I will save this. I have closed this. I come back to my Hadoop and I'm going to say stop all. So what this is going to do is it's going to stop all my services. Okay, so it has stopped the services. Let me do JPS. There is nothing available, and I am again going to say start all. Okay, so start all will start all the services. Let me show you in the pig script. Since I'm there in my window, if I go down to my pig folder, there is a file in the conf called as pig.properties file, and you see that in pig.properties file, see these are the two files that we need to change. Okay, FS default name is localhost and mapred is localhost:8021. That's the standard port numbers. So no reason to worry. So now I'm going to say JPS once again, just to confirm that everything is started. I'm going to say clear so that it clears the screen. And now I'm going to type pig. Okay. So since I've set the pig in the path, and this should work. Let's see if it doesn't work. I need to connecting to HDFS. See here, connecting to job tracker, and you see the grunt shell coming. Okay, earlier this is the two lines where the errors was coming. Okay, when it was trying to connect. Okay, so now there are the grunt shell. I want to show you my customer records. So I'll go down to my lab. In the data, I've got something called as customers. It's a huge file, but then I'll open it. There it is. So what am I having in this file? I am having the ID, the name, the first name, the middle name, the age, and the profession. Okay, so this is what I'm going to load as a comma separated value into my pig. Okay, so let me quickly go ahead and type that. So I'm just going to be a little bit lazy. I've got ready-made commands for this. I'm not going to type this. So I'm going to go down to customers. I'm going to go down to JP Morgan. And inside that, I'm going to go down to my, yeah. Let me get down to the exercises which I typically show them. So let me go to this is your Hive, and then we have got pig. Okay, Hive is there, there is pig. Okay, so look what am I going to do. I'm just going to explain the code. I'm going to load from input cust. So what is this input cust? Let me go down to let me come out of this, exit. Okay, exit semicolon. Okay, control C, sorry, this is pig. So control C will work. Clear. I'm going to say Hadoop fs space minus ls space slash input, sorry, input slash, and you would see what all things are there. And one of the file that you would see would be called as CUSTS, that is customers, there it is. And you would also see TXNS, that is transactions. So that's the file that I'm going to load, okay? And these are the two files that I'm going to use. So before I go ahead, just want to look at the questions to see if anybody has asked me something. Hey, somebody's saying it's quiet. What's happening? Let me go ahead. Okay, sorry, Srilal. In between that, I have just, okay, quit. Okay, sorry. Not exit. Okay, sorry. Okay, you're seeing the command. Thanks, guys. I'm used to Control C. Thank you so much. Okay, fine. So let me minimize this again. Good. Okay, coming back to the console, because only one processor, guys, I can see only in one place at a time. So in the bin, I showed you where it is. Let me get back to my data. This is how the data is. This is what I'm going to load from customers. Okay, 1, 2, 3, 4, 5, 5 columns, guys. Okay, and I've got a huge amount of customers. Okay, it's really huge. So let me close that. Let me go back to my command prompt, and I'm going to say, let me copy that command. I'm just going to be lazy. I'm not going to type the whole thing once again. So I'm just going to take up this command, and I'm going to say Control C, and let me type. I need to type in pig over here so that I can get into it. Okay, and there it is. It's connecting to the Hadoop file system, and then I'll say right click, and it got pasted, and I'm pressing enter. Okay, good. It's got loaded. Now I want to show only the top 100 records. So I'm going to say LMT, that's limit, and I'm going to say limit my cust for, let's say, top 10. Okay, and I press enter. Fine, nothing happens. Only when I say dump LMT, that's the time when it will actually create the code. So see here, it is actually MR plan before optimization 1, after optimization it is 100 optimized false, some of the commands, your buffer size, okay, what is the total input part to the process, okay, it has got the job ID, okay, it has got all of those information. Now if I open up my browser, I know you're seeing this, so I will say http://192.168.192.168.14. Yep, there it is. I want to show you the job tracker. Okay, you see here the default queue name is running. 1054 was the job ID, and you see here how it is running. Physical memory byte swapped. Okay, so map is 100%, reduce no need. This is complete. You see the reducer is running. The job was successful. So this is how you can go down to the job.xml and see what's happening. So when I look at that complete job, it will show you everything is completed. Okay, when I say back, it is running. Let me go back to my shell. See here, it's only 50% complete. So you could see that this is real time. Okay, you can see that this is running no such task. Okay, so it is actually completed. When I go down to this, okay, no jobs found because it's actually completed. So come back to this. There it is. So you see here how while it was running, it has actually gone down. It has shown me all those things. This was a job ID. Okay, what are the map time? What are the reduced time? Successfully read. I had about 10,000 records, so 999 records from the cust. It has stored all of those things into a temp memory. So you could actually get down into this temp memory and see what is available. This is the temp memory. Okay, so I need to look at this so I can actually show it to you. Okay, I'm going to select. Okay, let's wait. I'm just going to copy this for the time being. Okay, I've copied it. I'm in the grunt shell. You said I have to say type quit. Okay, lovely. Quit is for coming out, and I'll say let's not say clear. I'm going to say Hadoop fs space minus ls space. I put in that command, I press enter. Okay, so in that particular location, okay, it was only a temporary thing. It has already removed that particular thing. So let me only look at temp. Okay, I think it should be, hey, this is in, yeah, this should be in the temp location. So yeah, there it is. What we had given was I should have put in a slash temp to see if it is there. Let's see if it is there till even after showing the output, it should typically have removed it. There it is. It has actually removed that particular value, but then you can see here it has shown me the top 10 records. Okay, if you recollect, the first record was Christina Chang. Okay, this was the first record indeed. So this is how your pig would work. Let me go back to the questions to see if somebody has asked me some questions. Let me go down. Okay. Vikas was saying, what is the max map task capacity in the web page? Not clear on that question, friend. Should it be executed in the Ubuntu machine? Hey, I could have gone outside. Yeah, okay. So I could have tried this from another VM, but then I needed to change the pig.script to try it from another VM. Okay. So I have tried that earlier and it works. So how are you able to access the HDFS file systems on the PuTTY? That is the client machine. In fact, this is I'm sitting on the cluster right now, friend, because okay, I'm actually sitting on the cluster, and that's why you are seeing this happening. Okay, so I'm not there on the client machine. This was there on the cluster, so that's the reason I was able to see that PuTTY. Let me show it to you how I could do it from another VM. Okay, so let me test that. What would be the map reduce task for this example? See, Kaushik, every code that you write, okay, it has to be executed in a map reduce and given it to you, right? So when I say dump, it has to go down because the client wouldn't know where the records is, right? So that's why it went to the cluster, it fired those code, and it gave me this particular output, friend. Okay, so that's how it actually happened. So what I'm trying to do is I am going to try to start another Ubuntu VM and see if I could quickly show you this, because I would just need pig to be over there. Let me go back to the map reduce logic okay. The map reduce logic would be to simply select a inbuilt logic will be created by whenever you type something, whatever is based on that automatically. That's why what is the advantage of pig, Kaushik? It will abstract the map reduce creation from the user. So you don't have to create a map reduce program. It internally created that and given you the results, Kaushik. That is the beauty of pig. Okay, you don't have to do anything specific. It will do it automatically. Make sense, friend? Let me go back to the question section and bring it out. And for you, Vikas, in that page, do you see a map task capacity? So let me scroll up. You're talking about in the PuTTY window, Vikas, the max task capacity? Oh, you're there in Firefox. Okay, let me get back to this. So you were saying a max. Okay, this is the number of parallel things what you can reduce. So if you recollect, there is a property in mapred-site, the number of slots what you can keep for map and reduce, right? So this is that particular slot. The number of minimum mappers and reducers that you can have. Yes, 3 slots are there. So at a point of time, 3 mappers can be running. Let me show that to you. I can go down to the WinSCP. I hope the thing is near real time now. Hey, it's not necessarily, see, the splits are more than 3, that's right. If it is one split, it will typically be one mapper that will be running. You're perfectly right. That only shows you the max capacity, folks. Okay. So the other 2 are idle right now for this job. Yes, you're right, Vikas. The other 2 are idle for this job. So I go down to my not root, my lab, my software, my Hadoop, my conf, and in that there is mapred-site.xml, and in this I have kept, see here, if you see that day 2 I have mentioned this particular property, mapred.task your reduce task and your map task. Both of them I have kept it as 3. So that's how it is 3. Sure, Vikas. Thank you. So let me close this. Kaushik, does that understand your question? Does that answer your question, Kaushik, as to what is the map reduce logic, friend? Oops, no, cancel. I don't want to terminate it. Guys, I hope everybody is clear with this, friends. If there's any question, you can ask me. I'm going to go ahead with my demo now. So in the variable, I've got something called as cust. Sure, Kaushik. Send across an email. A short answer to that would be, whatever are the pig commands that you're writing, internally pig will convert that into a map reduce program, because look at this. Where is the CUSTS file? It's there in the HDFS. Who will be able to read that HDFS file? Only the HDFS via MapReduce programming. So pig converts every command that you're writing. Maybe it was a little bit abstracted from your, Kaushik, because the exercise was not done. If you do the exercise, you would have seen this happening yourself. Okay, so in the exercise, when you're running this, every pig command, when you say dump or store, would convert whatever is the output, whatever you are having, whatever is expected, all the logical plan will get converted into a physical plan and will get converted into MapReduce programs. Okay, so he understands that. So what is the code that has been written? That is what would be there in the job.jar file, and the class files will be there on the server. Okay, so if you are expecting to have a look at those class files in the temporary folders, you can get the class files, you can obfuscate that, and we can try looking at the MapReduce programs. It is possible, Kaushik. If you have anything else, feel free. We will take it offline, friend. Wonderful. So now I'm going to say, after this, I have got this. Now I'm going to say, again, I'm going to go down to pig. And it is again connecting. You can see the beauty when I use the up arrow, whatever was a variable that I have used earlier is available with me. Okay, I can when I use the up arrow. So I'm just going to show you one thing. I've quitted now. Okay, I'm just going to say group by profession, group my cust that I've created by profession. I put a single quotes and I press enter. Okay, see here, it's not able to see the alias because I've gone out of that log, right? So this is what I wanted to show you. But then those things are available for me. I can easily go ahead and load this once again. Okay, so that's something that you have to remember when you go outside the grunt shell. Okay, so now I can say group cust by profession. I'm not going to use my LMT anywhere. Okay, and now I could say describe profession, describe group by profession, and see here it's taking up the array. Just a second, I've got some additional programs running which is wasting memory. I'm going to quit that. Okay, see here it's a cust array, char array, long char array. Okay, fine. So this is done. Now I just want to show you something different. I'm going to say cust1, okay, is equal to load again my input cust. I'm just going to say so much, okay, semicolon, press enter, okay, and I'm going to say describe cust1, and I'm trying. Okay, so no, you needed to say it as. I'm just trying to show you how do we get the default value for something. So I could have just said load. It should have worked. I'm just wondering why that did not work, because load should have worked. Okay, let's say I'm going to say load, and I'm going to say what I call as pig Latin, so that because it's a comma separated value, so I'm going to say using, where am I? Too many windows here. I'm going to say load inputs at CUSTS using pig storage single quotes, comma, single quotes, bracket, okay, and semicolon, and I'm going to press enter, okay, and I'm going to say describe cust1, okay. I'm just loading that cust1, okay. It is not firing because I did not give it as a structure, it is not picking up that particular structure. So I needed to just check how the structure would be picked up, because I wanted to see, yes, the documentation says byte array. I want to say what is the actual data structure that has been used. Okay. Vikas was asking, MR is the only way to access HDFS. Heard from someone that Cloudera Impala does not generate MR jobs but can be used for ad hoc queuing. In fact, if I am not mistaken, yes, MR is the only way to access it from HDFS. So if Cloudera Impala is doing something, it is kind of an in-memory what they are doing. So are they communicating actually with the HDFS? I'm not too sure about that. If they're doing it, I would love to know how they're doing it, because so from what I know, I don't think so. The only way is using MapReduce, because that was the biggest constraint, you know. They were not able to use, in fact, one second, in Gen 2, you could use other programming stuff like MPI also. Okay, so I think the statement that only MR can be used is not quite correct over here. Yes, yes, yes. In Gen 2, you could use MPI, message passing interface, also to connect to HDFS. Okay. So, Pani, what are they saying in load over here? Okay, so what Vikas is saying, Impala is using an implementation over ANSI SQL. Okay, frankly speaking, I haven't got time to play around with Impala, friend. So if you have read that, that should be exactly be correct, Vikas. Pani, if you can let me know what is in load. Yes, in load statement after the pig storage. No, I'm just saying load so and so. Using pig storage should have been fine. Okay, Pani says give schema. So should I haven't typed that. So SCHEMA. No, I don't think so. Do not mention the data type. In fact, that's what I did, friend. So let's see what all are the values. It says couple of things are there. Anyway, so that's fine. So let's not bother about that. So I just wanted to show you how that would happen. So now I have got count by profession. So okay. So he's saying that you could just use that without giving the name. Okay. Let me see that one last time. So you're right. What I could do is I could say cust2 over here. Instead of giving the values, okay, he's just saying give the type, don't give, okay, cust ID. Just a second, guys. Got your point, Pani? I'm just going to remove this. Guys, what are we trying to do over here is to find out what is the default that is there for the type. Okay, that's what we're trying to find out here. Age, and finally I'm having my profession. Oops, profession. Okay, that would not have mattered. Okay, and I'm going to say describe cust2. Okay, you're right, this is a byte array. Okay, it said that it might get converted that into a char array, but then I need to check up why I assumed it as a char array. I don't recollect on what basis I have done that, but then this proves the point that the default of everything is a byte array. Thank you, Pani. Wonderful. So now I need to go ahead with my group by profession. I think we have done that, so I'll just type it once again. I mean execute it once again. We have already said group by profession, so you can see here I am having the group by profession, and inside that I've got cust ID, first name, last name, age, and profession. I'm grouping that by the char array. Okay, so that is the profession. Now I want to find out the number of customers by profession. Okay, so I'm going to say count by profession, and I'm going to say for each group by profession, and generate will give me the columns that I want, and I want the column COUNT. I want to count the customer. Okay, and I'm going to press enter. Okay, and I'm going to say store, because I would want this value to be there. Dump will only show me the value, whereas store will actually show me where the value is going to be. So I'm going to say store my count by profession into I've got a folder called as output, and I'm going to say inside output, and I'm going to say CBP, that is count by profession. I close my single quotes, I press colon, and I press enter. Oops, it's not able to understand count. Okay, my typo. I did count by progression. Silly mistake. Count by progression. Okay. Hey, what is this? See, if something goes wrong, this is what would happen. So I have said count by so and so. Okay, that is executed. Now I want to say dump. I want to say store. I just want to ensure that the values are right. PROGRE PROGRESSION. Okay, that's right. Okay, very embarrassing when you do something like this, but then that's fine. Typos are a part of life. Thanks, Vikas. I didn't see that. You guys have caught it, man. Like I said, only one professor, only only one processor at the time. Okay. So I have while this is happening, what we could do is you'll see that the values, whatever is there, it's going to dump that. I'm going to go ahead and keep the next thing ready now while this is executing. We have dumped it. Now I'm going to load the second stuff, Control C, and the transaction records. I need to show you how the transaction looks like. So let me go down to the data section. Okay, and in that I have got TXNS, a huge file, so couple of seconds for it to load it. Okay, and pick up the values. And what I'll try to do is that a subsection of this, I will mail it across to Vineet so that you guys will also get these files so that you can analyze like what am I doing right now. You could actually do that. So TXNS is what is coming up now. Hey, Pani, you were just asking me that. I saw it right now. I can share the data files and see the scripts. I would want you to actually try it out, but then I can sanitize the scripts and send it across to you. No worries. Should not be a concern. So my TXNS is coming up. Just bear with me. It's a 88 MB file. There it is. So this is something that we have got it from a credit card or a company, but then it's sanitized. Don't worry, there is no misuse of this. So it takes up an ID number. It takes up the date. Oops, what happened to this? In fact, it will go to everybody, Madhu. I'm going to send this across to, just one second. I'm going to send this across to the guys so that they can actually mail it across to everybody. It's not only some people, everybody will be getting this, friend. So the ID, okay, then it has got the value, what category it is going to work on, then individual machine that you are having, the location, the county or the state, and whether it is a cash or a credit. Okay, so pretty huge file as you can see. 80. Let me show you the size of the files. Okay, I have closed that. Let me minimize this. Just wanted to show you the size of the files. There it is. You should be seeing the size of the TXNS file and the size of your CUSTS. Okay, it's 88 MB file is what we're actually going to work on right now. So you saw that this is already done. So see here the total bags, if it was any, successfully read 9,999 records from HDFS, and see here it stored 51 records. That was a unique values into the output called as CBP. So I'm just going to cheat a little bit by just copy pasting these things. Okay, and I'm going to say, oops, I need to get out of grunt again. So okay, uh, okay, doesn't matter. Let me do it once again. I'm going to say quit, which is going to take me out of grunt. I'm going to say Hadoop fs space minus ls, and I'm going to paste, and I'll press enter, and you should see inside that, depending upon the number of reducers what you have, you will see this. And I am simply going to say, after this, let me copy this. Okay, oops, 2 times it came. So I'm going to say Hadoop fs space minus cat, and I am going to do this. So I'm going to cat the output whatever has been stored in that particular file. Hey, what's this? Okay, there was a small typo. It should have been just output. I have written something before that. Okay, so I am running this. Hey, what is this? In fact, I should not have a slash. Come on, I'm making silly mistakes. Okay, the mount path is output. So this is going to list you 51 records. There it is. You can see here what all are the categories and the 51 records. So what did I do here, by the way? What I did here was, I need to go down to grunt real quickly. That is what is pig. And we had grouped first group by profession, okay, and then for each member in the group we had generated count and the group name and the count of customers. There it is. For each in group by profession, generate count and customers. Okay, so this is what we had done, guys. Of course, you could, in the exercise what I'm going to share it with you, we could do more also, but then this is just to let you know what all are the 3 things. So I'm quickly going to join the other things. So I'm going to run the other commands real quick so that I don't want to spend more time on this, but then this is a good demo wherein you will understand what is happening. So I'm going to go down to cust 1. Just say cust. What was the original one? Okay, there it is. I run the first command. Then group by profession I want to run because I'm going to use it later on. Okay, group by profession. Cust by profession is what I have typed. That there was no typo over here. That's also done. Then I'm going to say count by profession. Okay, oh, sorry, this was progression. This is profession. I will have to say F. Okay, PROFESSION. Okay, count by profession. That's also done. I'm not going to dump it. Now I'm going to take up the second record. That is the transactions. And let me paste it over here. I'll press enter. So you see here, transaction ID, date, customer ID, amount, category, product, city, state, and type. Everything is loaded in TXNS. Now comes the magic. Okay, I can let's first only group transaction. So again, I don't want to type it out. I'm just going to say, oops, there it is. I'm going to say copy group transaction by customer. I type it. I press enter. That's fine. I'm grouping the transaction by customer ID. Now I want to get the sum total amount spent by every customer. Okay. I'm going to do a dump only at the last, okay, or a store only at the last. So now I'm going to do, of course, this file also will be shared with you guys so that you can practice. So now I'm going to copy this and I'm going to group my spend by customer. For every transaction customer, I'm going to generate a group and a sum of the transaction amount. Now I would want to order customer and show you how descending happens. So see here, I'm going to order and I'm going to do it in a descending way. So order customers beginning from the highest spender. So let me go back to my code. Okay, I am doing that. That's been ordered. Now I want to select some top customer. Of course, you can do it in the exercise later on also. But then if I want to dump this, my customer order, okay, by whatever they have spent, so we will just dump it. Okay, so I am going to say, because I don't want the record later on, I want to say dump customer order. This is going to be a huge thing. Okay, and I'm going to press enter. So you see immediately the pig has started all the codes. And let me look at the questions now to see if anybody is asking something. Yes, Sandeep. Do we know how much faster pig is compared as to SQL for medium, large processor, let's say millions of records? In fact, Sandeep, the actual example that was given to me by JP Morgan is for some of their analysis where they have got about 200, 250 people who wants to do some ad hoc analysis on the data set. Okay, these guys comes in at 8 o'clock in the morning. They want to do that, so they would want to have the data prepped up in some way. So when they were hitting the Sybase directly, the 200 and 210 analysts at any point of time, Sybase for the 10 million record, Sybase was giving a lot of performance issues. Okay, so what happened is they said that we need to do something, and about a year back they said that from the same example of Informatica, they exported the whole 10 million records into a particular file. From Informatica, they loaded that particular file onto HDFS, which was taking about 2 hours to 2 hours 10 minutes on an average, and they run the MR programs, plain MR programs. They were not using Hive or anything else, and that was taking about 12 to 16 minutes on an average, and then the guys were able to work directly on it. So the answer was again in HDFS. They again, Informatica picked up the analysis from the HDFS, and those guys were able to work on it. So yes, it is going to be difficult if it is going to be 10 million records. They were not using PIG. They were using MR directly. PIG is an ecosystem component that has been used if you are having unstructured data. For plain SQL, Hive is the best answer for you. So after this, we are just going to talk about Hive after this example so that you would see what is the advantage what Hive has. Because Hive is exactly SQL. Okay, it's a kind of a data warehouse. So that should answer your question, Sandeep. Okay, you're welcome, Sandeep. So just gave you an analogy. Is there something like user-defined functions in Hive? Very much. You have got UDTs in both, in Hive and in Pig. Both has got user-defined functions. So you see here that this is getting a little bit slow, but then can't help it. That's the way it is. We can't optimize this. You see here total input paths combined is 2. Okay. Sure, because today we will be giving some introduction. I'll be, like always, we'll be sharing this whole stuff with you straight away, and you will be, so that this week you can read through it, and next week there will be the actual theory and my demo and your exercise, friends. Okay, so it has taken it up into one had 2 parts as a job. This is what you see here, something called as job control compiler. Madhu, you're there. You can see this job control compiler. Madhu had asked me, how do I do job chaining? So what is happening here is actually internally there is a job chaining that is happening. Okay, the job control is the class which is doing the job chaining. So the output of the first one has gone into the second one, and then the second one is running right now. So this is job chaining that is happening right now, folks. So the mapper has gone in. There is two map IDs. Okay, this is one map ID that was there. Okay, see here, group by, order by. Oops. No, Vikas. Job chaining would mean a job consists of a mapper and a reducer both. So output of the first one should go into the second one. That is what is job chaining. Hope it is clear, Vikas. Depends upon the order. You specify the order. In this case, the first one was the job. Okay, there was a particular job which did something. Okay, and then the second one did the second work. Okay. So if you say dump, we dumped those things, but then internally it was order by and all that. So it converted that into two jobs. So you can see the actual URL over here, localhost 5030 job descriptions. So let this get finished. We had it's a quite a bit of record. You'll actually see it. You would see 83% complete. Guys, while that's happening, I hope this is for the 10 million record set. No. This is not for the 10 million record. This is for, I've got, I think, 10,000 records is what I have in this. Again, the processor speed and a lot of other things would matter, friend. This is not for the 10 million record. While this happens, just wanted to check with the others. A lot of that's nice, Vikas. So a lot of people have been communicating. Some of you have been a little bit quiet also, friends. Hope I'm connecting with everybody. There it is. Okay, so let me scroll up. Oops, that's the problem with this, man. I didn't realize it. I displayed the whole thing. Okay, I should have put it into that so that I could have shown you the actual record that's coming. But then you could try it. You could dump it, guys. You could store it. I dumped it. You could store it. Okay. So Gaurav, I'm connecting with you, friend. Kaushik, Abhishek, Madhu, Sandeep is talking to me. Srilal, thanks, Abhishek. Trevor, Vikas is talking to me, and Pani. Thank you, Gaurav. Thanks, Kaushik. Thanks, Madhu. Madhu also spoke about site distribution of data. So that's another topic that you can look at the definitive guide. If the job is running and if you would want to pass some data dynamically to a code, that is what is called as site distribution, and you can use the configuration object for passing it. Okay. Wonderful. So I'm sorry guys, I could not show you the complete output because this record was huge, and since the scrolling capacity was less, it is not scrolling further, guys. Okay, so it maxed out. So let's ignore that. You can actually try this yourself. So let me come out of this. I'm going to say quit. Wow, that was good. Because site distribution, that is configuration data, comes from HDFS. No, let's do a search, kind of a search engine. So you would want to do the search which is indexed in your HDFS. The search criteria is going to be passed into your mapper before it starts, right? So that is what is called a site distribution. The reason it's called a site distribution is because the data is not coming from the top via parameters. You're distributing it to the code so that it goes to all the node before the actual mapper starts at work. That's called a site distribution. It could come from, it might be from HDFS, or typically it could be external as a key to the program before it runs. So that's site distribution, friends. Wonderful. So I think I'm going to stop my VM now. So but that's the way with any inputs to MapRed, right? Exactly. So because the parameters to the MapRed is key value, right? And if the key values are specified in your data itself, I don't have to do anything. But if you want to pass something to a program, you have to do it in the site distribution technique with us. So let me get out of this. So I'm going to say exit. Okay. Oops, I exited. That's fine. Anyway, I'm done with this. Give me a second because it takes too much of memory, guys. So I'm going to say exit on my VM also. and I'm going to shut down my VM because it takes a lot of space. Are you sure you want to power off the VM? Very much. Thank you. So I have powered off the VM. I'm going to close my workstation. I'll close my Word document. Unnecessary memory usages. I'll close my WinSCP. That's also done. I'll close my browser, and let's start with the next slide. Let me get down into the slideshow. So we have seen quite a bit of things in Pig Latin. So Gaurav, you had asked me last time, will we be seeing something more in Pig Latin? You would have seen, we have seen quite a bit in Pig Latin. Now let's move on. The next ecosystem component. So what have we seen? We saw what is basically HDFS. We saw how to install on week 2 the stuff. Then third week we started with the MapReduce. Fourth week we started with Pig. And week 5 we are starting off with the next one, that's Hive. Okay, so let's talk more about it. So hey, I again lost my Windows. Okay, now I've got it back, and let me put this onto the slideshow once again. Okay, so where did Hive come from? It was started at Facebook. We saw that Pig was started at Yahoo, okay? So Hive was started at Facebook, where data was collected by cron jobs and stored it into a Oracle DB. The actual ETL was hard-coded using Python. They started with tens of GBs in 2006 to about 1 TB, and now it is about 10 TB per day. So you see that there is a Scribe server layer over here. There is the MySQL server layer. Data collection servers were getting it from the different locations and storing it into an Oracle database. Okay, so that's how the original history of Hive was. Why the word Hive? Anybody, guys? Why is Hive called as Hive? Any answers, friends? Why is Hive called as Hive? Beehive, that's right. So what is the peculiarity of a beehive? There is an analogy behind it. There's a reason why they are calling it. Like bees goes to the hive, computation goes to data. Not really. Well structured. Okay. The closest analogy would be maximum usage of space. Okay. Like another analogy was what people are saying is taking things from many places and storing into one place. Okay. That's one dimension to it. But then yeah, exactly. Gaurav says data is stored in cells like honeycombs. Yes, maximum utilization of the space. Okay. So Hive again needs to be there on the cluster. If you're doing Hive, it has to be there on your cluster, friends. Okay. So let's talk about what is Hive, and let's look at a couple of points on that. It's a data warehouse package built on top of Hadoop. So the beauty of this thing is once you have got partitions, in database you got partitions and all that. Once you got an appropriate partition and the data is already there in HDFS, you don't, for the first time for doing that, you require MapReduce. But once it's ready, you don't require MapReduce, okay? So that's the beauty. Let me elaborate more. You do some analysis. For the first time, it has to be on the data. You have to do analysis. So the output of the analysis, if it is stored, and when you search the output, if it is in a properly clustered way, partitioned way, MapReduce don't have to be fired. So somebody asked me earlier about the speed of all of these ecosystem components as compared to SQL. Hive has got wonderful speed. It's better than Pig, definitely. Okay. Because what I meant by partitioning here is breaking up the data into separate sections based on some column. We will talk more about it. This was a general term that I have introduced. We will talk more about it now. You'll see it in a couple of slides, friends. Hive was used for data analysis. The basic target of Hive were people who were comfortable with SQL. It is similar to SQL, and the language that we have is called as HiveQL. It is used for managing and it's used for managing and querying structured data. It abstracts all the complexity of Hadoop so that you don't have to learn Java and the Hadoop APIs. It was developed by Facebook and it was contributed to the community. And as of today, Facebook has been analyzing several terabytes of data using Hive. So Facebook is using Hive and it is using HBase. Okay. So we will see HBase in the next section. Okay. So the way I do it, is I do a part of one technology in one ecosystem and then take up the other one in the next one. So that's how we will do it. So two most common ecosystem components used is Hive and HBase. Let's focus on Hive. It's a kind of a data warehousing package. That's the general part of Hive. So just a visualization aspect of the points. Defines SQL-like language called as HiveQL. Allows programmers to build in custom mappers and reducers so that you can decide how many mapper numbers you want or how many how many mapper numbers you want. You can do that. It is a data warehouse infrastructure and it provides tool to enable easy data extract, transform, and load, friends. So just another dimension of Hive. If you want to look at the architecture of Hive, you would see that Hive has got exactly because this also uses MapReduce. So it abstracts MapReduce from you. It also uses MapReduce at the heart of it. So you have got the Hive layer on top of this. There is a CLI to the Hive. That is command line infrastructure. There is a web interface. You have got something called as a customized thrift server. All of the metadata is what is stored in the another location. So the structure that you want, if you want to store the structure can be stored separately. It is stored into a metastore. And of course you will have a driver, the compiler, optimizer, etc. All of those stuffs are there. So the Hive will talk to Hadoop and it will automatically create a MapReduce program and it will talk to the actual data that is there on your data nodes. The MapReduce programs gets passed via the job tracker onto your data node, onto your task tracker, which will execute it at the node layer, friends. So this is what is the architecture of your Hive. Let's see the next one. So what are the different components what we have? One, of course, the shell. Second, the metastore, that is the metadata that you have in the schema. You have an execution engine. You have got a compiler. The driver is a starting program. And these are all the different components what we have in Hive. So let's read all of these things. Okay, so I think one of you asked, Madhu was asking me, what is a thrift server? Thrift is another way of talking to Hive, okay? You could use a command, like in Pig, you could use a grunt shell, you could embed it into a Java program, you could use a Pig script, right? So same way Hive also uses its own customized Apache thrift as a language. So if you're using thrift, you would need a thrift server. That is it, friend. Make sense, Madhu? Okay, so thank you. So shell allows interactive queries like MySQL shell connected to a database. This gives an example. It also supports web and JDBC clients. It's a driver which handles the sessions, fetches and executes the code. The compiler will parse, plan and optimize. It's the execution engine which will be different stages. Okay, it's a collection of different stages, the MR, the HDFS, or the metadata. The metadata is a schema, it's a location in HDFS, or else you can do serialization also. So just an understanding of the different components of Hive. So when we talk about the metastore, there are three ways in which the metastore can be there. By default, the metastore is always embedded. So from the driver, it will be there in the Derby. Derby is an embedded database, so that is the default. If you're using a local metastore, you can store it into MySQL also. And I need to see how Cloudera is going to use Hive because in Ubuntu, when I type MySQL, by default, MySQL is there in Ubuntu version. So Cloudera should also have it. I just need to play around with it. I haven't done that until now, folks. In Ubuntu, I have done it multiple times. So in a local metastore, the driver will talk to the metastore, which will talk to MySQL. If it is remote, through the metastore JVM, you can server JVM, you can talk to MySQL. So what is stored in MySQL is only the metadata, friends. Okay. So that's how 3 ways you can have the metastore stored, metastore metadata stored. Either it could be local, it could be embedded, or it could be remote. Sure, Vikas. So he just wants to have a look at the Hive components. So let me go back. Okay, there you go. So if you can look at the Hive components and see if anything is not clear, friend, I'll explain that. Others also, if you have any questions on whatever we have discussed till now, please let me know. Communication is the best way how you will be able to share the information, friends. Okay, Madhu, we will be storing the metadata into MySQL, the schema into MySQL. Okay. No worries, Vikas. So what I'm going to do is I'm just going to go to the next page which talks each of these components. So you can have a look at that. Exactly. So the way Hive, let me scroll down. Okay, so this will explain to you what all are the different components doing. So have a look at this. If it's not clear, I'm there to help you. So typically if you want to do something like in a database, you need to create a table. Okay, the table would be stored in the schema. You'll be dumping the local input into the table. That's how it works. We'll see all of these things when we do the actual lab also, friend. Fine. Is it okay, Vikas? We have just got a couple of slides. See, driver is like our MapReduce driver program. Think in that way. Wonderful. Cool, guys. So just 2 more slides and then I've got a lot of other things, but then this will be sent to you. We will cover it next week. It's always better to read something before it's actually done so that you can understand what it is and you can ask questions also. We have done this. Now let's look at the data types what we have. Like every language, it's an unfortunate aspect, but we can't help it. Every language has got its own data types. So the primitive types are the Boolean types, the floating point which could be single or double precision, the string type, and the various integers which could be much more exhaustive than what we have. So tiny int, small int, and big int. Okay, Madhu, the execution engine over here, let me go back to see in what dimensions we have seen it. Okay, there we go. So the execution is something which is going to take the input from the Hive command, like what you saw in Peg, will convert that into the MapReduce, will pick up, communicate with the HDFS, will also coordinate with the metadata, what is there in the schema, and then load it. Where is the metadata in the Hive infrastructure, right? So Hive is going to be there in the same layer as where your MapReduce programs are. So typically the metadata part of it is there in the MySQL database or Derby if it is embedded. The MapReduce and HDFS are the components that Hive will talk to. So that's it in general, friend. Make sense? Okay, you said Hive is faster than Peg. Both use MR. How is it faster then? Okay, the reason is because Hive is for structured data. So a MR program on structured data is always faster. Whereas MapReduce can be used since it's stored. If I don't specify the type as a byte array, you could see that it is an unstructured data. Okay, it is from that perspective, friend. And you will see it actually getting, when you run the examples, you'll see the actual speed yourself, friend. Metadata is again a file. Metadata is again a file in HDFS. Yes, there would be a warehouse folder for every user created wherever Hive is, and you would see that. Metadata is again a file. Yes. But then if it is embedded, that means it is there in Derby database. Okay. If you want to see the structure of that, you actually create a table. Like how do you create a table and then you would load data into it, right, in a database. Same way table has to be created because this is a data warehouse, friend. Exactly. That's right. That's right, because it is really interesting, guys, if you see it. Okay, so let's move on. We saw what are the different types, and this is the second last slide. So if you look at the primitive types, the types are organized in the hierarchy where there is a number, double, big int, tiny int, float, int, tiny int. Okay, so this is just the hierarchy of the primitive types, how it is stored. And you will have the last part of it, that is complex types. The complex types can be built up from primitive types or other composite types using 3 operators. You could use structs. It can be accessed using the dot operator. You could use key value tuples, that's maps. It could be used using the element name notation, or it could be arrays, which is an indexable list. The elements can be accessed with using the notation where n is an index. So it is an indexed based array, how you can pick up your values. So again, it has got primitive types and it has got complex type, guys. Okay. So with that, we have seen what is PIG. We did some good demos. I'm going to share the stuff with you. We also will look at the Hive, just a very basic introduction. We will look more into it. The slides will be shared with you along with the recording. The exercises will be given to you. Start playing around with that. I will also send the data files and the exercises to run the basic commands for your PIG also. So we'll stop it over here, guys, for today. We did quite a good set of things. The definitive guide does not have a chapter for Hive. In fact, there is a book called as Hive in Action. Okay, it's a torrent. So I would suggest that you should torrent that book, and it is wonderful. So a book is always better than a presentation, so it'll go in depth, Sandeep. Wonderful. So thank you so much, Pani. So thanks everybody, guys, for taking your time and coming down to the class. Thank you so much. And like always, please fill up your feedbacks, friends, because that is what is needed internally. So I will really appreciate if you can give your suggestions also. That will be wonderful. Thank you so much. The name is called as Hive in Action. I'm going to type it, Hive in Action, and I'm going to send it to all. Okay, there you go. You should have got it now, friend. Sure. Thanks, Kaushik. So we will wrap it up for today, guys. And next Sunday, same time, we will start with our 6th lecture. You're welcome, Pani. Bye-bye. Bye-bye, everybody. Thanks, Srilal. Thank you, Vikas. You also have a great week ahead. Thank you, Abhishek. Thank you, Gaurav. Thank you, Mother. Thanks, Sandeep. Okay, guys, I think that's it for today. Bye-bye, Trevor. And I think all of us had said bye-bye. So let me wrap it up for today. See you later on. Bye-bye and have a great week. Bye for now.